In this video, we are going to be talking about factors and multiples. So before we get started, let's talk over some key terms that you're going to hear throughout the video. So the first is a factor. So a factor is a number that when it's multiplied with another number gives the number we're looking for. So it's a number that goes into another number. The kind of opposite of that is a multiple. So a multiple is a number that can be divided by another number without a remainder. So if you think of in elementary school or primary school, when you would count up or do some skip counting, you'd count up by 2s or 5s. Those are all multiples. So it's numbers that can go into as you count up, versus a factor being a number that goes into that number. So they're often confused because they do have sort of a similar definition. They're easy to mix up, but they are very different. So a factor goes into that number, and a multiple is numbers that that number goes into as you count up. A prime number is a number that only has two factors, itself and 1. So for example, 3 is a prime number because the only numbers that go into 3 are 1 and 3. 2 doesn't go into 3, and any number that's bigger than 3 isn't going to be a factor. So a prime number only has two factors, itself and 1. It is helpful as we're going through this if you can remember the first 5 prime numbers. It usually helps with a lot of different math and when you're talking about multiplication facts. If you can remember the first 5 prime numbers, that usually helps you, and they are 2, 3, 5, 7, and 11. So in order to find the factors of a number, there's a strategy or process that you can use to make sure you find them all. So the way that I like to do is I start with 1. So I obviously list 1 and that number because every number has at least 1 in itself as factors. Then I go up from there to find the pairs that multiply to give that number. And once you get to a pair where you have something like 4 times 4 or 5 times 6 where there's no other numbers in between them, then you know you've gotten them all and you can stop. Okay, so for example, I'll think, okay, does 2 go into this number, 3, 4, and let's kind of work my way up until I start repeating numbers. Okay, and you write them out as you go so that you don't forget. So for example, if I want to find the factors of 15, I'm first going to start with 1 times 15. And then I'm thinking about what other numbers multiply to give 15, and I'll work my way up from 1. So does 2 go into 15? No. Does 3 go into 15? Yes, 3 times 5. So does 4 go in? No. And now I'm at 5. I've started to repeat numbers I already have in my list, so I know I've gotten them all and I'm done. So the factors of 15 are 1, 3, 5, and 15. Okay, so I want you to try to write out all of the factors of 30. So pause the video, write out the factors of 30, and then start the video again when you're ready. So again, we're thinking of what number pairs multiply together to give us 30. I'm going to start with 1 and 30. Does 2 go in? Yes, 2 times 15. Does 3? Yes, 3 times 10. Does 4? No. 5? Yes, 5 times 6. And now I'm at 6 and I'm starting to repeat, so I can stop. I know I've gotten them all. And so the factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30. Okay, so you try these ones. Again, pause the video, list all the factors of the following numbers, and then start the video again when you're ready. Okay, so the factors of 25 are 1, 5, and 25. In 60, there's quite a few. 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60. And in 32, there's 1, 2, 4, 8, 16, and 32. So let's look at multiples. Again, multiples are numbers that you can count up using that number. So you're essentially using your times tables or addition skills in order to count up by the number that you're given. So for example, if I want to list the multiples of 5, I'm going to start with 5 and just continue counting up. So 5, 10, 15, 20, 25, 30, and so on. And so it's not possible to list all of the multiples of 5 because you can keep going on to infinity, but oftentimes the question will ask you for the first so many multiples. So I want you to try this one. What are the first 4 multiples of 4? Pause the video, write them out, and start it again when you're ready. And the first 4 multiples are 4, 8, 12, and 16. Okay, so I want you to try this one. List the first 5 multiples of the following numbers. Pause the video and then start it up again when you're ready. Okay, so for 7, we have 7, 14, 21, 28, and 35. For 12, we have 12, 24, 36, 48, and 60. And for 22, we have 22, 44, 66, 88, and 110. Okay, so let's work on writing prime factors. So we can write a number as a product of its prime factor. So there's some keywords in there. Let's break this down. Product means numbers that are multiplied together. So we can multiply some prime numbers together in order to get the number that we have. And this can really help us when we're looking at the greatest common factor or lowest common multiple, which are things that help us when we are finding common denominators with fractions and problems like that. So let's take a look at this. So let's look at 84, and we're going to write it as a product of its prime factor. So it sounds a lot fancier than it is. Basically, you can think of any 2 numbers that multiply to give us 84. So I'm going to start with 84, and I'm going to draw sort of like a tree. And as I go down, I'm writing out the pairs that get to 84. So for example, I can do 2 times 42 will get me to 84. And now I'm going to look at the 2. Is there any numbers? Can I break that number down any further? No, because 2 is a prime number. And so we want to keep going with each branch until the numbers at the bottom are all prime numbers. So 2 is a prime number. I can't break that branch down any further. But I can look at 42. And again, I'm thinking of any 2 numbers that multiply to give us 42. And I'm going to do 2 and 21. Again, the 2 branch here, I can't break down any further, but I can break 21 down into 3 and 7. And now each of the bottom of my branches are all prime numbers, and so I'm done. So with these trees, depending on what numbers you choose, your branches might look different. You might have chosen a different pair of numbers that go into 84 or 42. But your bottom of your branches should end up to be the same. So even though the middle part may look different depending on the pairs that you've chosen, at the end you'll still have these ones. And we can write it as a product, meaning I'm just going to multiply them all together. So you can check your answer, and in a calculator, if you do 2 times 2 times 3 times 7, you should get back to your original number. And so we wrote 84 as a product of its prime factors. I want you to try this one. I want you to write 45 as a product of its prime factors, so you can pause the video and then start it up again when you're ready. So I'm going to start with 45 and think of 2 numbers that multiply to give us 45. And the pair that I thought of was 5 and 9. So 5 I can't go down anymore, that's a prime number, but 9 can be broken down into 3 and 3. Again, if you chose different pairs here, that's perfectly fine, as long as your bottom branches work out to 3, 3, and 5. So your final answer is 45 equals 3 times 3 times 5. So it's okay if this looks a little bit different, as long as you've gotten this same final answer. Okay, and you try this one, write 70 as a product of its prime factors, pause the video and start it again when you're ready. Okay, so 70, I broke that down into 7 and 10. Now the 7 is a prime number, so I can't do any more with that, but 10 can be broken down into 2 and 5, and now I've got all prime numbers, so 70 equals 2 times 5 times 7. Okay, so let's use that then to find the greatest common factor. So greatest common factor, or GCF, is the largest number that goes into all of the chosen numbers. So it's the largest one that goes into them all. Okay, we can find greatest common factor by writing numbers as a product of their prime factors, so doing those trees, and then multiplying all of the ones they have in common and leaving out any they don't have in common. So for example, if I want to find the greatest common factor of 36 and 24, so what's the biggest number that goes into both 36 and 24, I'm first going to draw those trees and write them out as a product of their prime factors. So 24, I'm going to break down into 2 and 12, and then 2 and 6, and then 2 and 3. And 36, I'm going to break down into 2 and 18, 2 and 9, and 3 and 3. So 24 I can write as 2 times 2 times 2 times 3. And you'll notice when I've done this, I've written them in numerical order. And that will help you when you're trying to see which ones they have in common. 36 I can write as 2 times 2 times 3 times 3. So what do they have in common? Well, they have a 2, they have another 2, and they have a 3. What's different about them is that other 2 and 3, that's not common. So I'm going to take the pairs they have in common, and I know that the greatest common factor then is going to be 2 times 2 times 3, which is 12. Okay, so I've taken what's common and I've multiplied that together to get 12. So 12 is the biggest number that goes into both 36 and 24. Okay, you try this one. What is the greatest common factor of 18 and 12? Pause the video and then start it up again when you're ready. So 18 can be broken down into 2 and 9, and then 9 can be broken down into 3 and 3. And then 12 can be broken down into 2 and 6, and 2 and 3. So altogether 18 is 2 times 3 times 3, and 12 is 2 times 2 times 3. So what do they have in common? They have this 2 and this 3. So the greatest common factor is going to be 2 times 3, or 6. Okay, you try this one. Again, pause the video and start it up again when you're ready. Okay, so we're going to take 30 and break it down into 2 and 15, and then 3 and 5. And 40 we're breaking down into 2 and 20, and 2 and 10, and 2 and 5. So altogether 30 is 2 times 3 times 5, and 40 is 2 times 2 times 2 times 5. So what do they have in common? They have this 2, and they have this 5. So the greatest common factor is 2 times 5, or 10. Okay, so let's look at lowest common multiple. So this is the smallest number that is a multiple of the chosen numbers. And so this is really helpful when it comes to finding the lowest common denominator between numbers. Okay, so we can find this by writing them as a product of their prime factors, finding the greatest common factor, and then multiplying that by the leftover numbers. Okay, so it's sort of like we find the greatest common factors, you do everything we did before, and then you just have one extra step to find the lowest common multiple. So for example, if we remember back to this question where we found the greatest common factor between 36 and 24, we're now going to find the lowest common multiple. So we're going to find the probability trees. So we're going to do the prime factor trees. So 24 can be broken down into 2 and 12. 12 can be broken down into 2 and 6, and 6 can be broken down into 2 and 3, and then 36 is 2 and 18, 2 and 9, 3 and 3. So altogether 24 is 2 times 2 times 2 times 3, and 36 is 2 times 2 times 3 times 3. So we need to look at what is common between these two. We have 2's, 2's, and 3's. So my greatest common factor is 2 times 2 times 3, which is 12. Now to find the lowest common multiple, I'm then going to multiply 12 by the bits that are left over. So I have a 2 and I have a 3 that are left over. So to find my lowest common multiple, I'm going to do 12 times 2 times 3, which is 72. And so you'll notice when we found the greatest common factor, your answer should always be a number that is smaller than either number that you were working with before. So 12 is smaller than 36 and 24. But when we are looking at a multiple, remember multiples happen because we're counting up by these numbers, and so your answer should be bigger than 36 and 24. So I want you to try this one. I want you to find the lowest common multiple of 18 and 12. So pause the video and then start it up again when you're ready. Okay, so we're going to break 18 down into 2 and 9, 3 and 3, and 12 down into 2 and 6, 2 and 3. So all together, we have 2 times 3 times 3, and 2 times 2 times 3. And so what is common between those two? We have this 2 and this 3. So my greatest common factor is going to be 2 times 3, which is 6. And again, remember 6 is going to be smaller than 18 and 12. To find my lowest common multiple, I'm going to take that 6 and I'm going to multiply it by what's left, which in this case is 3 and 2. So 6 times 2 times 3 is 36, which again is bigger than 18 or 12. Okay, and you try this one, pause the video and start it up again when you're ready. So 30 can be broken down into 2 and 15, 3 and 5. And 40 can be broken down into 2 and 20, 2 and 10, 2 and 5. So 30 is 2 times 3 times 5, and 40 is 2 times 2 times 2 times 5. So we have a 2 and a 5 that is common between them. So the greatest common factor was 10. To find the lowest common multiple, I'm going to do 10 times 3 times 2 times 2, which gets me 120. Okay, so I want you to reflect back on how you did during this video and give yourself a thumbs down, a point, or a thumbs up. So you're having trouble solving problems with factors and multiples and you need some help, you need some more practice with this, or I can solve problems involving factors and multiples, I don't need help or practice. So think back on how you did throughout the video and give yourself one of the 3 rankings.